My name is Nina Kirchner. I'm the director of the Bolin Center, and I'm pleased to be the host for today's Bolin Climate Lecture given by Professor Roberto Buizza from Italy. But Roberto will actually connect to us from London today. The Bolin Center is named after Bert Bolin, and you will hear about Bert Bolin in just a few seconds. The Bolin Center is also Sweden's largest center for climate research, with approximately 400 members at Stockholm University, at KTH, Royal Institute of Technology, and at SMHI, Swedish Meteorological and Hydrological Institute. This week, we celebrate climate science. We started this morning with a science seminar by Professor Buizza, and we are continuing now with the Bert Bolin Climate Lecture. And from tomorrow on, we will have our climate festival, which this year will be running in digital form. Usually, we would gather in Stockholm University's beautiful Aula Magna to listen to the Bert Bolin Climate Lecture, but today we have it as a Zoom webinar, and I will give you some practical information in a second. After the practical information, I will hand over to Professor Henrik Cederqvist. He is the Dean of the Faculty of Science at Stockholm University, to say a few words about the Bolin Lecture and Bert Bolin. And after that, we will give the word to Professor Cynthia de Witt. She is the chair of the board of the Bolin Center, to introduce this year's climate lecturer, Professor Buizza. And then, when Professor Buizza will give his lecture, we will be able to listen to that, to see his presentation, and afterwards we will have time for questions. And this brings me to the practicalities. You will be able to ask questions either by using the chat function, question and answers in Zoom, if you have downloaded and installed it. You cannot do that if you just run it in your browser, or you can raise your hand, and then our team behind the scene will later on moderate it and give you audio so that you actually can ask your questions. And we will repeat this information, this technical information, just when Roberto has finished. And with that, I hand over now to Professor Henrik Cederqvist, Dean of the Faculty of Science at Stockholm University. Thank you.
Okay, so thank you, Nina. As Dean of the Faculty of Science at Stockholm University, I'm very proud to welcome you to the 2020 Bert Bolin Climate Lecture. The lecture has the title Climate Change, How Can We Motivate Transformation? And it will be given by Professor Roberto Buizza from Scuola Superiore Sant'Anna in Pisa, Italy. More about the lecture later, but first a few words about Bert Bolin. Bert Bolin was one of the founders of the Intergovernmental Panel of Climate Change, IPCC, and he was its first chairman, a position which he held for 10 years between 1988 and 1997. As you know, IPCC has been very influential and is very influential in relation to climate research and climate goals, and it was awarded the Nobel Peace Prize together with the former US Vice President Al Gore in 2007. Bert Bolin has a very strong connection to Stockholm University. He earned his PhD at Stockholm Högskola. This organization later became Stockholm University, and he received this degree already in 1956. After that, he became professor in meteorology at Stockholm University, and he was in this position between 1961 and 1990. His research focused on climate change and the carbon cycle. These are topics which, of course, are highly relevant today. I should mention also that the Faculty of Science has 8 profile areas, and one of them is indeed climate, seas, and environment. So climate and environmental research has a very prominent position at our university, and these are also growing fields in society and at the university. Bert Bolin, he passed away sadly in 2008, and from 2008 and on, a distinguished Bert Bolin climate lecturer has been invited to Stockholm to give a lecture and a science seminar, which we heard has been today, And this has been given then at the Bolin Center for Climate Research. Again, I want to welcome you to the 2020 Bert Bolin Climate Lecture. And I now give the word to my colleague, Professor Cynthia de Witt, who will introduce today's speaker and the lecture. So please, Cindy.
Roberto Buizza is currently a full professor of physics at the Scuola Superiore Sant'Anna in Pisa, Italy, as Henrik said. He took his degree in physics from the University of Milan, and he did his PhD in mathematics at the University College of London. He also has a master in business administration from the London Business School, which is, in a sense, quite unusual. He's an expert in numerical weather prediction and ensemble methods and predictability. He's previously worked at the European Center for Medium-Range Weather Forecasts, where he was a key developer of their ensembles and served as head of the predictability division and as lead scientist. After taking his professorship in Pisa, he's been working to establish a new initiative on climate with the support of the 3 Scuole Universitarie Federate in Italy: Sant'Anna, Scuola Normale Superiore of Pisa, and Scuola EUSS of Pavia. Professor Buizza is very active in communicating climate science to the public and working on initiatives aimed at actions to deal with climate change. Please welcome Professor Robert Buizza as this year's Bert Bolin Climate Lecture. Please, Professor Roberto Buizza, the floor is now yours.
Thank you. Thank you very much, Professor De Witt. Thank you, Professor Sedekis. Thank you, Professor Messori from Uppsala University, who has actually proposed my name to the panel. It's my honor and privilege to give this lecture, and I hope we will go through some interesting conversation about climate and how we can motivate transformation. Let me also thank all the team of the Bolin Center, especially Annika, Eva, and Laila, who with Professor Kitchener really helped me a lot in preparing the lecture. So I'm going to share my screen. I'm going to give a lecture, and I'll make sure that we have time at the end of the lecture for questions and answers. Okay, so you should now be able to see my screen and follow my lecture. So the title, how can we motivate transformation? I want to put an emphasis on this word motivate, because I think it's a key area where we really need to work all together to make progress. Let me motivate my choice by looking at the current situation, the current crisis of COVID. And there is an interesting paper by Barkman in the Harvard Business Review, where actually he discusses why are people not motivated to change? And in particular, he was discussing motivate to address climate change. He was stating 4 points. First one, we overvalue benefits in the short term relative to the long-term benefit. Second point, climate change is a nonlinear problem, so it's difficult to understand with a linear thinking what can happen in the future. And people are not used to think about systems that might evolve not linearly. Third, many effects of climate change are distant from most people. We might live in an area where the effect of warming or of drought is not felt, or it's felt only very rarely. And fourth, the future is always more uncertain than the present. So because there is uncertainty, why should I act for something that I might not know? So as you see, there are keywords here: communication, temporal dimension, understanding the problem, understanding its linear or nonlinear evolution, the need for action to tackle big problem, motivation, and uncertainty. So these are the keywords that we will discuss during my lecture. the plan is to go through three main group of slides. The first one will deal with this understanding. So we need to understand, we need to know how a science of climate change, how the Earth system is evolving. We need to communicate then how the system is evolving. We need to communicate facts. We need to use the right language and bring examples. And finally, clearly, we need to act. But to be able to act, we need to motivate people and to motivate also decision makers and politicians. So this is the plan, this is the roadmap of our lecture. We'll go through understanding first, then communicate, and then action. But before we move to the first point, I want you to do a poll that I've designed. I'll give you 30 seconds to answer to the question. So if Annika can please bring up the polls. I might need to stop sharing the screen. Okay, this here is the poll. So please take 30 seconds to answer to these questions. This is just for me to understand and for all of us to understand how much we really know about the system. So as you all have voted, we will share with you the results of the poll, and then we continue during my lecture. So you have another 10 seconds to go. Yeah, I give you another 5 seconds. Okay, I guess, Annika, you can end the poll and share the results. Okay, so essentially the questions were about a few aspects of climate change. First one is whether the concentration of CO2 that is above 400 ppm since 2007 has been above that for the first time in 2.5 million years. So whether clearly, if you answered true, this was the correct answer. People who said the false are wrong. The second question was about whether mankind and human activities are the principal responsible for this, and 67% of you answered yes and 33% no. Third question was about what's the amount of CO2 emitted by a person living in China versus a person living in Europe. I asked whether a person in China has been emitting between 1991 and 2014 2 times what the person living in Europe has emitted. The correct answer is false. It's actually European people living in Europe who have emitted twice as much. And the fourth question is whether per kilometer a person traveling with a fossil fuel car emits 10 times more than a person traveling by train. 83% got it right. So essentially what you have more or less answered correctly to this question, which is very good. But as you can see, and you are all people who are aware about the climate, I would expect that possibly people who are denial or people in position, in high-level position in politics or in decision-making sometimes don't really know these facts. And I think it's very important that we communicate these facts very clearly to be able to convince them. So back to our understanding point. The first point that I want to make is that we clearly need to advance science. We need to advance science to understand the evolution of a system and not only the evolution of a system, which we can do by applying physical laws to design models, by adding processes to the model which we use to study the climate, but also we need to understand better the impact of climate change and the impact of inaction, of not dealing with climate change on society, on health, on populations. And this is my third point, the fact that probably the link between our models of the Earth system and models that simulate the impact of action or inaction versus climate change should be probably improved. Again, on science, I asked you a question about the 400 parts per million. 83% of you answered correctly, and this is in fact what you can see, for example, by a paper like the one that I quote here, which clearly show that although CO2 concentration has been oscillating in the past 800,000 years between values of 200 to 270 parts per million, we really need to go back to about 2.5 million years ago to find levels of CO2 similar to the one we are at now. Unfortunately, if we continue with the current amount of emissions, we will probably reach levels that the Earth hasn't seen for 30 or maybe even more longer million years ago. Now, this is a key aspect that we need to communicate to everyone. Second aspect that I think it's important to understand and to communicate to the people is the fact that although the climate system has some natural oscillations and temperature has been going up and down, we can, if we look at the observation of the past 100 years, 1,000 years, and the reconstruction of paleoclimate, we cannot really see a time when temperature has increased by so much and so rapidly. So if we look at the value we were of anomalies in temperature in 1900 and where we are now, we are more or less warm the average global climate by about 1 degree. What you see here is a reconstruction of the average global temperature by 8 different authors using different techniques. So you see oscillations in each of these curves. These oscillations are linked to natural variability. If you look at the scale by how much actually these oscillations have been varying, it's some tenth of a degree, maybe 0.2, maybe 0.3 degrees, and normally over rather long time periods. Never before the 20th century, and especially never before the last 70 years, we have seen such a dramatic rise of temperature. This is another aspect of science that we need to communicate very clearly to everyone. And the fact that the globe is warming and is warming fast comes from observations. And again, this is something else that we need to clearly communicate to everyone. The fact that the world now is about 1.3 degrees warmer than pre-industrial time, and that we keep seeing months or years where the temperature is very high. 2019 was reported, for example, by the Copernicus Climate Change Service as the warmest year in the past 40 years, at 1.2 degrees warmer than the average anomaly of, and that the average temperature between 1980 and 2010. Another aspect that we need to understand and we need to communicate is the fact that even with a warming climate, we can have extreme cold events. This is essential to communicate because otherwise we have people like the President of the United States that says that, okay, Niagara Falls have been freezing in January 2019. There's been a lot of cold weather, so where is climate change? we really need to communicate clearly that under a warming climate, it's possible that we have more extreme cold events. The reason being that if this is a representation of a climate of a system before warming, with some events with warm temperature and some events with cold temperature. With global warming, what we have done is to shift this distribution to the right, so the average temperature is warmer than the average temperature before. We have, on average, higher frequency of warm events. But because the system is more energetic means that the atmospheric flow can change more. We can have jet streams, for example, that change shape more than before. We can also have a higher frequency of cold event, higher than we had before. So the fact that we can observe very cold events doesn't mean that the climate isn't warming. I mentioned uncertainty and Berger in his paper mentioned uncertainty as one of the reasons why people don't take actions. Well, uncertainty is taken into account by scientists who look at how the climate is changing, how it has changed, and how it will change. And a lot of efforts and research is actually put into trying to design models which are capable to estimate and simulate the uncertainty in the future. So what is interesting to note here in this report from Hawkins and Sutton, 2009, is that if you want to do climate projection up to 2100, you really need to take into account three main sources of uncertainties: the internal variability of a system, the fact that the model has some uncertainties that need to be taken into account, and the fact that the scenario of the future, so how much CO2 will actually increase, what the population will be in 2080 and beyond, what level of economic activity we will be in 30, 50, or 80 years from now. So all these three sources of uncertainty are actually taken into account when the scientists are designing models and are making this type of climate projections looking into the future. So let me recap what I've said so far on the first point of my talk roadmap, which is understand. So I said that it's essential to study the Earth system to better understand its evolution and its dynamic. I didn't go into details to talk about tipping points, but we really need to understand better what's happening, for example, to the deep ocean currents, to be able to understand whether the system will undergo some unprecedented changes. Point number two, we need to improve our estimate of the impact of climate change. So we need to develop coupled physical, economic, agronomic, energy models to be able to really see not only what's the impact of climate change, but also what's the impact of inaction, of not taking measures, mitigation measures onto the future. And third, we need to improve our uncertainty estimation of the future projection. Second point in my talk is about communication. Communication is essential in this field because to be able to address climate change, we all need to act, from us as single individuals to decision makers and politicians and the key persons in charge of the main corporations in the world. So I said before, I touched before a few points that we need to communicate, the fact that natural variability cannot explain what we witness, for example. The other point that we need to communicate very clearly is that mankind is the main cause of climate change. There is no doubt about that. And this can be proven by different ways, supported by physical arguments, by what the physics of a system say would happen if you keep increasing the concentration of greenhouse gases in the atmosphere. It is also supported by numerical experimentation with complex Earth system models, which I'm showing here. So in black here you see the evolution of the temperature, of the average global temperature from 1900 to 2010. In green, you see a simulation using these Earth system models of a past climate done by keeping the concentration of the greenhouse gases to the same level as they were in 1900. As you can see, this model simulation is an ensemble, so you see a band of possible temperature anomalies. Simulations are able to simulate what happened to the Earth climate up to about 1960, but then keeping constant the level of greenhouse gases doesn't make it possible to simulate the rise in temperature that we observe. It's only when you include human factors in your simulation, when you take into account the fact that greenhouse gases have been increasing, that aerosols have been increasing, and so on, that your model simulation are able to reconstruct the observed climate. Second very important point that I think we need to communicate very clearly is that there is responsibility, that certain countries have to take responsibility of a situation where we are. And how do we, what's the best way to try to understand this aspect of responsibility? I think we should really look at the amount of CO2 emitted, not by total country, but per capita, per person. I think CO2 per capita, and it's not only me suggesting that, is a just measure of responsibility in this aspect. So what you see here are data from World Bank of emissions per capita. You can download the data from the World Bank site. Emissions per capita of each person living in America, in Canada, Australia, Russia, China, Europe, and India. What you clearly see is that people living in different areas of the world emit differently. And this is partly due to the fact that some people have access to more wealth and more energy and are actually using more energy, sometimes even to have the same quality of life as others. And second point is that clearly some regions economic activity is different than others, and this can justify why in some countries, for example, the emissions per capita is higher than others. For example, look at Australia and Canada. Now, it's interesting to compute, to sum the amount of CO2 emitted per capita during these 25 years. Why is it interesting? Well, we all know that CO2 emitted CO2, the CO2 that we put in the atmosphere stays for a very long time in the atmosphere. So even if we stopped emitting CO2 now, it would take decades for the concentration of CO2 in the atmosphere to start coming down. So there is clearly a level. It's very relevant to look at how much CO2 has been put in the atmosphere in the past 20, 30, 50 years from now, and not just look at the value over the last year or the last couple of years. Okay, so if we sum up these contributions, we get to this amount of total greenhouse gases per capita in tons of CO2 equivalent accumulated from 91 to 2014. And here you can clearly see that there are certain countries which have emitted much more than others. And I would say that we need to communicate this very clearly and use this type of information to try to trigger and motivate change, especially from the countries that have caused the problems. Another important point that I touched upon was this issue of uncertainty. What I would like to say, so I said before that scientists, when they design models to try to understand how the climate will evolve, they try to take it into account and they try to simulate it best. And I would say also that with weather prediction, we have learned how to deal with uncertainty, estimate uncertainty, and take actions, even if we have uncertain information. This is an example of a probabilistic forecast of tropical storm Sandy that hit New York in 2000. As you can see, 10 days before the event, we were not sure whether the tropical storm will go. So it was the red line shows the actual path. The shaded line indicates where the tropical storm could have been 7 to 10 days after the start of the forecast, which was the 23rd of October. Sandy made landfall in New York, or close to New York, on the 30th of October. So despite the fact that the forecast had some uncertainty, people were able to use the forecast, get ready for possible worst scenario, plan actions, and start getting preparing and for what might have happened. Communication implies a choice of language. As scientists, we tend to, well, we work with colleagues and we tend to use a very technical language when we talk among ourselves. But I think it's extremely important, especially with climate change, that we make an effort, as much an effort as possible, to communicate in simple words the key concept, what we know about the system, and also what we don't know about the system. And that we try to engage with the whole community and use any means we have at our disposal to communicate. And here I'm showing examples. There is a poetry from a student from Fridays for Future of Italy, Alessio Hikikomori. This is the word he uses on the web. He sent it to me about 3 months ago after we had a conversation online about the climate. And so poetry is a very powerful means to communicate. Architects are designing new buildings to clearly signal the fact that we need to change. This is a new building designed by Architetto Boeri in Milan, in Italy. Theater can be used, and music. Music is also very powerful mean of media of communication. So let me recap what I've said so far on my second point, which is communication. So we need to state the facts, including their uncertainty. I think it's important that as scientists we clearly say what we know for sure, especially about the past, and what we know less accurately, for example, how the system will evolve in the future. But we should also make clear that the fact that there is uncertainty in our projection is not an excuse for inaction. Take the example of Sandy. We need to challenge the fake news, and we need to challenge them, not only stating the facts, but also asking the people who deny the fact that, for example, mankind is the principal cause of climate change, by asking for robust data, facts, and theory to back any argument which is put forward. And I would say we clearly need to use any means to communicate. And this is especially, I think it's especially important because we need to have all the communities involved in addressing this problem. For example, I've been working the past months with architects who are designing the Biennale di Venezia, which this year is going to be about architecture. And they will actually display some as pieces of art, some text that we scientists wrote to the politicians of Italy, trying to ask them to act. So I want now to pause for a minute and ask you to do poll number 2. So I'll stop sharing my screen and I will ask Annika, please, to launch poll number 2. So poll number 2 deals with, you have about 30 seconds. It should make us thinking about how prepared we are to act and whether we can act, whether we are enabled to act as we would like to act. So it's 4 questions, coupled by 2 by 2. So if you could please answer to them, you have another 10 seconds. 5 seconds. I hope that this polling will engage you a little bit more into this distant lecturing. Okay, thank you very much for voting. So Annika, can you please show the results? Okay, very good. So the first question was about whether we are all ready to use public transport, bike, or to commute on foot to reduce our climate, our greenhouse carbon footprint. And the answer is yes, 96%. Second question is about enabling us to do it. So the question was whether we have access to public transport, bike lanes, and footpath. And it's good for me to hear that 94% of you confirm that. There's a little difference, but I was expecting maybe even a larger difference about that. The third question was about working or studying from home, whether we could or we will be ready to work like 2 to 3 days a week from home to reduce again our carbon footprint, and about 85% of us said yes. And the fourth question was about whether we are allowed, or whether our workplaces would allow us to make such a choice to work from home to reduce footprint. And it's interesting to see that only 66% said yes, which clearly means to me that there is a lot more probably to be done to be able to make progress. And to make progress, we need to act. And I move to the third point of my lecture. We need to act to really decarbonize the way we live. Okay? We said at the beginning, and we look at what the Berger and Harvard Business Review reported about why can't we act. It's a complex system, there is uncertainty, the future is distant. Yes, okay, good point. But at the same time, if I think about the past 3 months, 4 months, and all the crises we all went through, I must confess that there is at least one good piece of news, which is the fact that the complexity of a problem we had to deal with didn't prevent us from acting. The fact that uncertainty about how this disease was evolving and spreading didn't prevent us from acting. Clearly, I mean, probably, and we will know it a posteriori when we start looking back with insights and more accurate data, we could have probably managed it better. No, by listening to the science and taking action earlier and trusting prediction. But I would say that the positive piece of news is that we as society, we have been able to confront and deal with a complex and uncertain problem. The negative news is that we have been probably too slow to react. We should have listened more to the science, and we should have taken action early and trusting predictions. Okay, and the parallel with climate change is clearly evident when I say this. Okay, now ideally we should try to not to repeat the errors that we did with dealing with this disease, with climate change. So how can we reduce our carbon footprint as individual, for example? This is a simple exercise that you can do by simply trying to collect from the web numbers like how much CO2 the average person on an average household in Europe emits. And these are the computations that I've done. So on the first table, you see the emissions of CO2, which is about 2.3 tons CO2 per year, linked to our the way we eat. Okay, and as you can see, and as you know by reading what has been published in the papers, that there is a strong, a large amount of emissions are linked, for example, to meat, to beef, to lamb, chicken, and so on. Okay, so this is the 2.3 tons of CO2 emitted by the average person linked to food. Then there is another 2 tons linked to housing, electricity and heat. Another 1.2 on average linked to traveling by car. Unfortunately, on average in the world, only 0.5% of the vehicles are clean, are fully electric. 99.5% are still not clean. 0.04% by train. Car is the most used transport, and also public transports are still very much combustion based, and another 1 ton per capita linked to flights. Now, what I want to show here is that by simply making some changes in our lifestyle, we can reduce with 6.5 tons per year by about 35% to 4.1. How? Well, we can think about the food we eat, for example, and eat less beef, less lamb, less chicken, and go from 2.3 to 1.4. We can be more efficient in our households and increase efficiency, increase insulation, maybe keep the temperature 1 degree lower and go down and save maybe 20% in efficiency. We can try to convince ourselves or our parents to shift to an electric car and go zero on the emission linked to car and use much more the train and much less the airplanes. So if you do these choices, which are all perfectly feasible already now, tomorrow, you can immediately see that the average person in Europe would go from emitting 6.5 tons to emitting 4.1. Clearly, this is what we could do as an individual. This is not enough to address the problem. The problem is so big and so that we need really to rethink the whole way we live. We need to think to transform Industry 4.0, which is what everyone is talking about, to what I would call Industry 5.0. Industry 4.0, which is a lot of automation and Internet of the Things and so on, is not enough. We really need to take out CO2 from all our processes and from transport. Think about renewable energy, clean transport, energy efficiency, reduction of the amount of energy required to build the same type of goods, change lifestyles, and so on. Okay, and it can be achieved. The effort that we need all to do doesn't require a massive amount of a GDP. It's enough, and these are estimates coming from, for example, IPCC or from think tanks like the Energy Transition Commission. It's enough to invest. IPCC talk about 2.5% of the world GDP, for example, to limit warming to 1.5 degrees. The Energy Transition Commission talk about 0.5 or even less than 0.5% of GDP per year to reduce the carbon footprint of our action. We must transform, for example, the way we produce energy. And the last 10 years has shown that by increasing demand, we were able to trigger new technologies and new developments, so that the cost of a solar energy has gone down by a factor of 5, from 3.3 to 0.9, so by 73%. And even for wind power, the last 10 years has seen a reduction in the cost of production by 60%. So the more we demand for clean energy, the more companies will invest in reducing the cost of the production, and the easier it will be to achieve our targets. So, point act. What did they say? Well, we need clearly to listen to science. We need to trust predictions. Okay, even if they're uncertain, we need to say that it's uncertain, but this is the best that we have. And I would say that the climate projections are fit for the purpose, which is to guide our decisions. We need to make proactive choices to reduce emissions. And we need to ask decision makers and politicians to take actions. Last point of my talk, motivate. I think these images by themselves should motivate everyone to change. The fires that affected California in 18 and Australia in 19, the droughts, for example, in January 2020, and the flooding, the extreme events, okay? How can we motivate action? Well, here is another example from today, from the current crisis. It's a paper appeared in Harvard Business Review in April 2020. People were saying, sure, the governor said to stay at home, but they are overreacting, really. Maybe the virus is bad in some part of the country, but I don't know a single person who has gotten it. So, and besides, many people who get it are fine anyway. So what's the big deal? So how can we motivate action if people think like that? Berger says that we need to, that there are 3 ways. First one, to highlight the gap between your thinking, your position, your actions, and what you actually care. Pose questions. For example, if you want to try to convince a person to eat more healthy, instead of saying junk food makes you fat, maybe a better way is to do you think food is good for you? Junk food is good for you. And ask for less, and then gradually build up requests. So if you think about the quote that I said, one way to respond to such a person would have been to highlight the gap. Ask what they would suggest an elderly grandparent or a younger sibling to do. Would they want them out interacting with possibly infected people or not? And if they think, no, they should not, then ask, well, why do you think it's safe for you to get out and not obey to what the people ask you to do? Individuals can trigger actions. And when I was preparing this lecture, I mean, the people that came up to my mind are giants like Gandhi, like Martin Luther King, like Rosa Parks. No, single individuals can induce others to follow. So we, as single individuals, if we start acting, we can induce and trigger action. Problem is that, for example, if you think about the struggle for civil rights, it took them 20, 30 years. No, they started fighting for them in the 1940s. Rosa Parks, 55, Luther King, 63, the Alabama famous bridge march in 65. It took many years. Can we afford to waste so many years for climate change? I don't think so. I think we need the help from governments. And this is my call from this lecture to governments and decision makers, that they must act now to help us as individuals. They need to make us able to take decisions that lead to reducing carbon emissions. Without a clear message from the government, without legislation, without a rethinking of the tax levers, that can trigger a reduction of CO2. Without the enforcement of policies aiming to reducing CO2, I don't think we will go very far. Okay. And now again, connecting to the current situation, the COVID-19, the fact that a lot of money is going to be invested in the economies of every country to try to restart it. The plea for many individuals, and here I'm quoting some bullets from a think tank from Italy, from Minima Moralia, who has been trying to design a set of requests to the government on a way to restart the economy, but decoupling it to carbon emissions. So they mentioned, for example, to reallocate subsidies that are now in environmentally harmful practices to accelerate decarbonization, to increase funds for energy transformation, to increase funds to improve building. So you can restart the sector, for example, the building sector, but you can also, at the same time, since the governments are putting a lot of money, enforce that this is done with an increased efficiency and so on. Okay. So let me conclude my lecture. I touched the following 3 main points: understand, communicate, and act. And I think if we make progress in the 3 and think about how to motivate people by using the right communication levers, by showing how to act, we can make progress. Okay, so my conclusions are that we should all work together to improve our understanding of a physical system and the impacts of climate change on humankind, its complexity and uncertainty. We need to all work together on communicating the facts, including their uncertainty, and not afraid to say that, because I think we have all the tools to deal with it. We also need to communicate that we have all the technologies and all the resources we need to shift and decouple economic growth from the growth of emissions. And we need to start acting as individuals, because we can actually show examples and convince people to follow us. We need to act as individuals and use our vote, for example, to induce governments to take actions now, immediately, and stop talking about long-term targets, but talk about clear actions that need to happen now. And with this, I hope you have enjoyed my lecture. I thank you again, of the Bolin Center, and who has invited me to give it. I stop sharing my screen, and I will be happy to take questions. Thank you very much.
Okay, thank you very much, Professor Roberto Buizza, for this informative talk. So at this point, we invite questions from the attendees, and you may either write your question in the question and answer, or use the button raise your hand. And if you do that, we can give you audio, so you have the possibility to ask your question verbally. So I suggest, Roberto, that you go to the question and answers, and perhaps we can start from the top, as for now, and start with the first question, if you would like to answer that one.
Okay, thank you, Annika. So I'll take the first question from Tatiana Oviedo, who says, I want to know better how to reach people. Relevant authors, papers, organizations focused on how to motivate people for social change and social engagements. Well, how to reach people? I have been trying, for example, I have started actually working more in this area only since the end of 2018. Before that, I was really working a lot more with my scientist colleague to develop your system models that I talked about. And I immediately first understood that there is a demand for information from many people. And every time people ask me to go and give a lecture, Would it have been in a church, at a ONG organization, in an undergraduate school, at a university, at a think tank, an energy association? I have accepted the challenge and I've given it, because I think we really need to inform as many people as possible. It's incredible how much ignorance there is on the problem that we're facing, especially at the top level. So my suggestion is use any opportunity you are given to communicate. So I'll take a second question from Sabine Undorf of University of Stockholm. Says, thank you for a great presentation. Just wondering why you chose to show emissions per capita from 91. Is that where the data start? Do you think integrating emissions is pre-industrial? Okay, so I've chosen 91 to now because the database I have actually have reliable data since that, and unfortunately it stopped in 2014, this database, which is, the beauty of this database from World Bank is that it's very consistent, so you have access to emissions for all the countries in the world up to 2014. Unfortunately, not to be behind that. Why didn't I go back even further? I think the main message is clear and loud enough, that there are certain countries, the rich countries of the world, the European countries, America, Canada, Australia, that are really the countries who need to show how to deal with the problem. So yes, maybe going back to another to 1950 would have changed a little bit the number, but I don't think the main message. Annika, do you want to give a floor to someone?
I would like to, but we don't have anybody who has raised their hand quite yet. But you are most welcome to do so if you would like to ask a question verbally. So, now we have many here. So I will give the floor to you, Team Dahl, and I will give you permission to speak. So please try and ask your questions, and we'll see if we can hear you. Team Dahl.
Hello. Yep. Can you hear me okay, Roberto?
Yeah.
Okay, my question was about, you said we have to engage and challenge fake news and correct those responses. And I was just wondering whether you thought that might be a bit of a trap in terms of engaging with a framing which is putting energy into that and putting attention towards a certain corner of the debate and a framing which has been created intentionally without an interest without curiosity in science. And so you sort of gave two strategies. One was refuting fake news, and the other one was communicating in other channels. And I was just wondering whether the first strategy could be a bit of a trap, and we should focus on communicating more out through other media and not being drawn into that.
Yeah, it's a good point. I so far tried to engage as much, but I must confess you that I've refused, for example, one type of engagement because I thought it was a bit of a trap. So my suggestion is that if we are able to engage with deniers on the right level, for example, if they are prepared to discuss key scientific points and in a scientific way, and have a proper debate and a proper confrontation, we might want to do it to convince the public and the media that actually what the deniers say doesn't have any foundation. Unfortunately, what I see is that, for example, in the news, very often there is one denial or messages from a denial versus messages from one scientist. And this can give a false impression that actually it's a 50-50 debate. It doesn't represent the fact that actually 95% of the people support what the scientists say, and it's only maybe less than 5% or even less than 1% who deny and what is happening. So I think we need to show probably also to the media people that this is not the case. And I think that at one point, in the right terms, we might need to engage also with denials. Back to you, Annika.
All right, so let's do another question, and I would like to give the word to Tom Nicholas. So I will go ahead and allow you to talk, and please ask a question. Tom Nicholas.
Hi there. I just wondered about something on one of your slides to do with, you wrote something about 0 kilometer food production, and I've seen conflicting opinions on whether or not that's globally the most sustainable thing to do, both from a CO2 emissions point of view and from like biodiversity point of view, because the argument is that shipping food, unless you fly it by air, is like a negligible fraction of the emissions of producing a food altogether when you account for land use. So there are some commonly cited examples to do with like, it's very important not to eat beef where forest was deforested in order to grow it, or if you grow tomatoes in a greenhouse in Britain, that uses more energy than like growing them in Argentina and then shipping them over on a massive cargo ship, because the emissions per tomato of shipping it is actually not that high. And I just wondered whether you had any sort of resources or thoughts on that difficult trade-off.
Okay, so my understanding is that there is a big part of a CO2 emission linked to food, which is due to transportation. Maybe up to 25% of emissions linked to food is linked to that. So, given the fact that we really need to act at a 360 degree on reducing emissions, I would say that any action going in the right direction must be supported. I'm not saying that we must only rely on 0 kilometer food, but we have definitely to aim to have as much as possible 0 kilometer food, 0 kilometer agriculture. We must redesign supply chains and shorten them, really to try to have an impact. Unless we act on all the sources of greenhouse gas emissions, it will be extremely challenging to do it. Okay, I hope I have answered your question. Annika, there is an interesting question from Charlotte, which I think is relevant. Charlotte Flodin, who says, what have you done to reduce your emissions? What has been most difficult? So I'm very much in favor of what people say, walk your talk. So we've been trying as a family. Also, I must say, we have a lot of push and motivation coming from our 3 children who have been pushing us in that direction. So we have been, I moved to an electric car. It's not easy to move around with an electric car, but it can be done. I commute with an electric car. I travel only by train, long distances in Italy, and I've never taken a plane anymore to go around in Italy. So train and electric car. I've been trying to reduce emissions from my flying. I was due to come to Stockholm by train. I planned a trip like Miss Turber, Greta, has been done many times when she, for example, she visited the Pope. I wanted to come up by train and give a lecture and come back by train. So I'm now giving it from London. So I've been trying really to do as much as possible. I've been trying to shift what we eat. We've been trying to install, and we are going to install photovoltaic panel to essentially provide the electricity to our house. So we have been trying to do it. What has been the most difficult? Well, the most difficult part, I think, is that I find it extremely surprising that there are no more incentives. So the electric car that I'm using costed 10% more than a normal car with a combustion engine, and putting in a photovoltaic panel is going to cost a lot. So this is why I think government needs to do more to enable. change. Back to you, Annika. Do you have someone raising their hands?
We do have a couple of words in their hands. Perhaps we can finish up with one last question, and in order to try and keep the time, this will probably be the last one. But I suggest that we can keep the chat open after the seminar, and we can also chat if there are more people who would like to interact with you. But I will give the floor to Georgia Savito. I hope I pronounced that right. So, Georgia, I will now allow you to talk. So go ahead and ask your question.
Perfect. Thanks a lot. Thanks a lot for quite an inspiring presentation, Professor Buizza. So my question is whether you have any experience on whether using data that are a little bit more personalized than the global one, the ones that you've shared today, have a bigger effect on motivating people to act. For example, I was reflecting on how big of a factor aviation is in certain countries, including Sweden, compared to, let's say, a country in Southeast Asia, for example, or Africa, and that is a huge difference. And so I was reflecting whether showing the global picture then doesn't show the clear picture for when communicating, let's say, to an audience in Sweden or in Italy, and vice versa in another country.
Yes, so when I was preparing my talk, I actually had some more slides that I prepared, and one of them was about trying to relate more to your audience when you try to convince them. And I mentioned individuals and examples. I think examples from people in your community can help convince people to move in one direction. So I think telling the story of people you know in your country who have managed the transition, have decided to make a transition, show that it's possible, that they didn't really have to go back to live like in the medieval time, but they simply had to rethink how they use their time, how they use the resources that they have. Probably would convince more the people than telling story, than simply giving average numbers. So I had to make a compromise, and I tried to use both. But I think you are raising a very good point. And I would suggest that to convince people, I would try to tell stories linked to where the people that you want to convince are. So if you are in South Asia, I would use examples from South Asia and show what you could do if you live in South Asia compared to what if you live in Sweden or in other countries. So I think a very good point. Yeah.
All right. Thank you very much.
So, Annika, what do you mean that I can continue answering with the chat?
Exactly. I will give the word from Nina now, and she will take over for a couple of minutes. But then we can leave the webinar on if you would like to answer.
Yeah, I can stay on for another 15 minutes or so after Nina or closes, and I can try to pick some of the other questions. Okay?
For sure. Okay. Just give me a minute.
All right. No. All right. Thank you very much, Roberto, for a fantastic Bolin Climate Lecture 2020. Usually we would give you a huge applause and would also give flowers. We cannot do it right now, but I promise we will make it up. I would also like to thank the audience who joined us on this experiment and holding the climate lecture in a digital form. That was only possible because of Annika Granebäck and Laila Islamovic, which you don't see, but they have everything in their hands behind the scenes. So a big thank you to Laila and Annika. And everyone would normally, if we had the lecture at Stockholm University, be invited for coffee and cakes. This was wrong. What we can do is we can invite you to the Climate Festival which starts tomorrow in digital form. You just go to our website and you find information there. And as we mentioned earlier, Roberto is happy to stay on in the chat for another 15 or 20 minutes so that you can communicate with Roberto in the chat and get more questions answered. And with that, I say thank you so much and welcome to next year's event in whichever form this will be. Thank you so much.